Hello, so this video is going to be a summary of the derivatives of the reciprocal hyperbolic functions. So these functions were COSECH, SECH, and COTH, so derivatives of reciprocal hyperbolic functions. So yeah, we've got COSECH, which was the first one that we did. So number one, we differentiated cosec of x with respect to x. And when we did that, the result we got was negative cosec of x multiplied by coth of x. So very similar to how we differentiated cosec, so the trigonometric function, but this time it's just the analog of that result, but with the hyperbolic function instead. And where is this function valid? Well, it's valid for all x values in the real numbers apart from 0. So obviously cosec is defined to be 1 over sinh. Sinh evaluated at 0 is 0. 1 divided by 0 is undefined. So cosec of x evaluated at 0 is undefined, but every other real value is defined. So that is how we define the cosec function. So it's got a domain of every real number apart from 0, and so the result holds true for every real number apart from 0. So yeah, so the next one we did was SECH. So when we differentiate SECH, the result we got was negative SECH of x multiplied by tanh of x. So again, very similar to the trigonometric analog. So very similar to when we differentiated sec. So we got sec times tan. This time we get negative sech times tanh. And that's basically because when you differentiate cosh, you get sinh rather than negative sinh, because when you differentiate cosine, you actually get negative sign. So that's why we actually have a negative sign here instead of the trigonometric analog. And again, this function here is indeed valid for all real numbers. So I mean, if you insert 0 into that, well, sech of 0, well, that's just 1. So 1 over 1, cosh of 0 is just 1. So yeah, so this is valid for all. Sorry, I've not written the notation correctly there. So for all x in the real numbers, this is valid. And just a little sketch of the sech graph. So I think we did this before. So y equals sech of x. So it's actually an even function. So just like how the cosh function is an even function, 1 over cosh is also an even function too. So something like, let me try and do that again. So something like this, where you've got 1 up there, and as x tends to infinity, sech tends to 0. As x tends to negative infinity, sech tends to 0 too. So yeah, something like that, and it is indeed an even function. So sech of x is the same as sech negative x, like that. Okay, cool. So that was that one. And then when we differentiated the COTH function, so the hyperbolic cotangent function, the result we got, again, very similar to the, well, pretty much exactly the same as the trigonometric analog of this. So we get negative cosec squared of x. And if we consider where this function is valid, well, it's valid for all x in the reals, again, apart from 0. So coth, so if we recall what coth is defined as, so coth of x is defined to be the same as cosh of x over sinh of x. So therefore, we know that coth evaluated at 0. So that's going to be cosh of 0. Cosh of 0 is just 1. Sinh of 0 is 0. This is undefined. So yeah, we can't have coth evaluated at 0. And also a note, so cosh of x over sinh of x. So this is actually just identical to 1 over tanh of x. So when we had our trigonometric functions, something we made note of was this down here. So when you had cotangent of x, the definition of that was cos of x over sine of x. But this was not necessarily the same as, so not necessarily equal to 1 over tan of x. And that's due to it's due to the asymptotes of the tan function. So the tan function has asymptotes at pi over 2, 3 pi over 2, 5 pi over 2, and so on, and negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on and so on. But sine is defined at those values. Sine is, in fact, either 1 or negative 1 at those values. So this cotangent function is defined at pi over 2, 3 pi over 2, 5 pi over 2, and so on, and the negative versions as well. But 1 over tan is not defined at those values. So yeah, that was just something we made note of. But with the hyperbolic functions, it is true that cosh of x, sinh of x, sorry, cosh of x over sinh of x is exactly the same as 1 over tan of x for all x values apart from 0. So for all x values in the reals apart from 0. And that's because sinh of 0 is 0. Cosh over 0 will just be undefined. So yeah, that was just a note that we made in the previous videos. But yeah, all of these 3 derivatives here are again what we did in previous videos, and those were the 3 results that we got.